Hello everyone, thank you very much for joining me again. Today we continue our discussion about multi-tenancy. Thank you very much for being here. If you are watching the event live, don't forget that you have a live chat there. I always have an eye on the live chat and you can ask me questions or start discussions. If you are watching the event recorded, as usual, you can ask your questions in the comment section or follow me on Twitter and LinkedIn. Last lesson, the previous week, we discussed about multi-tenancy and we have been a little bit disturbed about a bug in version 3.03 in Spring Boot, but we still managed to see how we can implement the resource server that validates tokens coming from two authorization servers. We only discussed a very simple scenario where both authorization servers issue JWT tokens and they presumably implement correctly OpenID Connect. So you only had to configure a couple of authentication managers. You had to specify the issuers' addresses, the URLs, and that was it, because the framework took care of everything else. But it's not always the same easy. Sometimes you need to either integrate with authorization servers that don't necessarily implement the right way OpenID Connect, or you simply need to have multiple authorization servers where some of them use opaque tokens. Or you have a different situation where you can't simply just use the defaults, and we know that it's very often in real-world scenarios where defaults can't be directly used. So today I'm going to show you how to go deeper into the customization of multi-tenancy, and you will learn how to customize multi-tenancy for that you will be able to apply to, I would say, any scenario. So what we learned today is the deepest way of configuring the authorization server. That's where the pre-configurations, self-configurations don't work, and you need to customize the authentication yourself, and then you can have one or more authorization servers and you can have them in any way you'd need. So I will spare some time using the projects that we already implemented last week. That's because, well, it doesn't make sense to rewrite them from scratch if you don't remember something, or you haven't seen the previous lesson. You can anytime go back and see it on this channel because it's free, and that's why I will prefer to spare some time and reuse the three projects that we use. So we have a couple of authorization servers, and of course we have the resource server. So remember that we have used an Authentication Manager resolver at that time, and as I've said a little bit earlier, we just chose the simplest of the examples where we have considered that all our multiple authorization servers use properly OpenID Connect. So with this case, you only need to specify the issuers' addresses and everything else works fine. Again, let's try to go a little bit deeper, and I'm going to comment out this bin and see what happens with a different example, a little bit more complex, a little bit more complicated even, that would assume that I want to use two authorization servers, but this time one of them doesn't issue JWTs at all. It only issues opaque tokens, so that already complicates a little bit my example. So how do we do that? Well, I'm still going to need this kind of a bin, because as I've said in the previous lesson, this is the way in which you customize at the lowest level your authorization server. So I need to still add the bin of type Authentication Manager resolver. So this is where in the end I will return something. Actually, it will be, and I can even write it as a lambda expression. So it's the request, the HTTP request, and then this would be the variable representing the Authentication Manager resolver. And then the question is, how do we know if the authentication has to be done on the authorization server using the JWT, or on the authorization server that uses the Opaque token? And that's something that mandatory has to come with the request. So this is the place where now we have to implement a bit of logic to tell our resource server, depending on the request, which is the authorization server that the request will be authenticated against. So you need somehow to have your resource server choosing. There are different, of course, there are multiple ways in which you can think. Now it's custom, it depends on the application. It's an infinity of possibilities. You can even have a situation where you go through all the authorization servers and you try with every one of them, but usually you will have something on the request telling you what kind of token you have, or maybe based on the URL, somehow you will know which is the authorization server you need to ask, or at least in this case the resource server, your backend application, needs to ask for authentication. So here is where we will actually have to implement a bit of logic. So it will not be, I guess, that simple anymore. It will be something like if, and then the condition based on the request, else. So that means here we return one of the authorization, one of the Authentication Manager resolvers, and here we return the other one. So it should be something like this in the end we want to implement. And of course you can go into the direction where you customize completely the authentication managers, the authentication providers, but Spring Security still offers you for the most common cases implementation, so you don't need to do that yourself. So we know that we can say something like Authentication Manager A1 or whatever. In real world application it should have more suggestive names. So it's provider manager, and then the provider manager receives as a parameter the provider itself, the authentication provider that will be called by the manager. So then it's A2, and then we can assume a very simple condition for the moment of something saying if the request contains a header named type which is equal with JVT, then we assume this is equal to JVT. Then we assume this is a request to go to the authorization manager using JVT. So let's call it JVT and this one Opaque. Okay, so that's in our case the logic. It's simplistic, it's a demonstration purpose logic. In a real world scenario it really depends what you implement there and what exactly you will have, but for us I think it's more than enough to understand what we need to do. So now we have two authentication managers. One of them is the one that we will define to have the responsibility of acting against the JVT, while the other will be the one acting against an Opaque token. So, and then I will go and configure the authorization servers to be one of them providing JVTs, one of them providing Opaque, and then we should be able to test the full solution and demonstrate it's working accordingly. What can we do now to avoid writing the providers ourselves? Because I mean, JVTs and Opaque tokens are known solutions. It's not something that we should need to really customize ourselves the logic behind. We only write our own authentication provider in case you really have something so custom that that you don't have any other solution. But for the most general cases where you choose between the known JVTs and Opaque, then you have already implementations provided by Spring Security. And remember, guys, what I'm always telling you about customizing how security works. I don't really recommend that a lot, and the reason why I don't recommend it is because customizing things and going outside of standards usually makes you more vulnerable, allows you to implement vulnerabilities, and you might not even know you do that. So what we can do here is, for example, for the JVT authentication, we can use a JVT authentication provider, which is basically containing the implementation for JVTs, while here it's something like Opaque token authentication provider, which of course, as you guessed, it contains the logic for Opaque tokens. So that's it. The only thing we need to now to make sure we provide is, for the JVT authentication provider, we need a JVT decoder. And let me do something like this. Let me actually try to put them somehow in the JVT, in the parameters. So I will make them injectable. I will make them beams. I make them beams because, you see, beams are components of, you think about Spring application as a puzzle. So I like to have things pluggable out and pluggable in. And when I build a Spring application, I try to take the responsibilities out and put them separately in bins. Because you might want to ask me, why don't simply just define the JVT decoder there in the method? Could you do that? Yes, of course. In this case, I could do that. Even in a real world scenario, I could define that in this method. But then it will not be as easier to test, for example. Think about testing in the future. I would like to have the possibility to independently test the JVT decoder that I use in my application. So see, it's very important, at least the way I see it, to decouple the components so that they become them independently, easier to change, easier to test, and so on and so forth. So that's why I would do something like this. And then the same I would do with the Opaque token Introspector, which is basically the object that will allow us to configure the Opaque token authentication provider. So something like this, and then provide this a parameter. Good. And now we have the logic, we have the authentication providers. Yes, I know I didn't write one from scratch. If you want me, I will schedule a separate video where I really write one from scratch, but we have already gone through that in one of the first lessons of this Spring Security playlist, didn't we? Because you've learned at the very beginning, I think it was one of the first lessons where I taught you the backbone diagram of authentication and authorization of Spring Security, and you know, it's filters, Authentication Manager, authentication providers. And then at that time, because we were discussing basic authentication, we went to user detail service and password encoder. We still keep the same logic here, the same design here. So we still have filters, manager, provider. So that's why what we are actually doing now is providing here the component that chooses through one of the managers that each of them has to delegate to a provider. So this is the provider, this is the provider. Okay, and now we have to customize to give all the needed details to our providers to know what exactly we want from them. So if I would basically try to start this at this point, anyway, I can't, because I have a syntax error at the moment, because I have to provide the two parameters somehow here. So let's actually define those two beans as I said. So I'm going to define a bean of type JWT decoder, public JWT decoder, JVT decoder bean, and then the second one is public Opaque token Introspector bean. I use return null for the moment. I will come back. I just want to escape completely the syntactic error I have here. So here it is. So I'm calling the bin methods, and now we have, you can clearly and easily see, we configure an Authentication Manager resolver, that we discussed in the previous lesson. As the name suggests, it gives the right Authentication Manager that the resource server needs to use. So then the resolver will delegate to the provider based on the condition that we have specified, and we need the two beans, the JVT decoder, for specifying the JVT decoder we need for the JVT token in case of the authorization server using JVTs, and the Opaque token Introspector to specify the introspection endpoint. Because remember, when you use Opaque tokens, it's called Opaque for a reason. It doesn't contain information, so the only way the resource server can get the details about the user is calling the introspection endpoint. So what options do we have? What options does the dependency in Spring provide us already for a JVT decoder? Nimbus JVT decoder is the default one, so I'm going to use it as well. So I'm going to say something new, Nimbus JVT decoder, and as a parameter it needs a JVT processor. No, I can't do that. I can do that, but it's much more easier to actually use the builder. So it contains a builder, and the easiest way is just to say Nimbus JVT decoder, because we only now rely on the keys endpoint, don't we? So you don't want something more exotic. So then you can, if you want that, then Nimbus already provides you a possibility to just build an instance of type Nimbus JVT decoder and providing the keys endpoint here, and then you call the build, and that's it. So let me see, one question in the chat. Hi Laurentiu, is there anyways just one security filter chain even if we have two bin of that type? I got confused on your first episode of OAuth 2. I'm not sure if I understand you can have multiple bins of type security filter chain, but they will be in a chain. So at some point you will reach in the one of the next filters. So think about it as a chain of responsibilities. But I'm not sure exactly what is confusing you. Maybe the two bins that I created in the authorization server at that time. And if that's the case, then I will come back. Maybe check me. Find me on LinkedIn, and then we can discuss there, because I feel it's not a moment now to separate the discussion, okay? And I will clarify it for you. So we have the Nimbus, and then I just realized I don't have authorization servers too. So this is one of them, port 6060, fine enough. And the client uses Opaque tokens, okay? So the first one uses Opaque, port 6060 uses Opaque tokens. I can even start it now to make sure I can say I have my authorization server. And I think the part that's confusing for you about the question until my authorization server starts, I think it's what is confusing for you is why we have here two bins, one bin of type security filter chain, and then the second one here. I think that's what you find confusing. But the idea is that one of them is for configuring the authorization server, while the one is the part about the web application itself, because you don't necessarily need to always have form login. So that's why you have two of them separated, and you place the order annotation to know which is the first and which is the second. Okay, we started it, port 6060, if I correctly remember. Does it? Okay, port 6060, and then I'm going to choose the second one, and I'm going to verify that it's on a different port, because otherwise I will not be able to start it, port 7070, and then I will verify that this one is non-opaque, so it's a JVT because it has this part commented out, and by default, if you don't set the token format, then by default it's JVT. So if I start this one, now I can claim that I have 2 authorization servers, one running on port 6060. The one running on port 6060 is issuing opaque tokens. The one running on port 7070 issues JWT tokens. So I have exactly what I want. I have 2 running authorization servers issuing different types of tokens. And if we manage to implement something like this, providing different authentication providers, then you know basically how to customize absolutely anything in terms of your resource server. So it's not using the defaults anymore, okay? It's using something really custom. Of course, now we do use, because it doesn't make sense and we don't have the time to like literally implement the logic ourselves for Opaque and JVT. Not that we can't do that, but it doesn't make sense because Spring Security provides us the implementations. But if I really had something so custom that I couldn't have used this and that, then I'm still able to configure my resource server by simply implementing my own authentication provider. And then we need an opaque token introspector, and we have 2 possibilities. I do recommend you use the Spring opaque token introspector because the other one would also need you to add some more runtime dependencies. So I can use the Nimbus as well, but I would have to go on Mavens and find a few more dependencies and add them to my POM XML, while the Spring Opaque should solve that itself. So Spring Opaque token introspector is the one that we will try using. It's very simple to create the instance. You only need to provide the introspection URI and the client ID and secret, which are needed when calling the introspection URI is secured via HTTP basic. So let me go here and fill in the gaps, and this is it. And then I have 3 parameters: the URI, the client ID, and the secret. And now I have to get the values. Now I will put them right here. I will hard code them. Never do that in a real world example, in a real world app. In an example it works, like mine. In a real world application, you always need to put anything that depends on outside factors such as the environment, inner application properties, and anything that is a secret value such as a password, another kind of credential, a private key, anything that needs to be safe and away from eyes of the public, is always kept in a vault. Okay, when you design, it's not you usually, it's the DevOps department or whoever designs the environment. In your case, they will provide you a vault. If they don't provide you a vault, you are asking for a vault. Anyway, you will have a vault. You don't put passwords and secret stuff outside of a vault. They will still end up in environment variables, so you will still just take them from using the value annotation usually in a Spring Boot application. So it's nothing different in terms of code, but just remember where you store your passwords, store them correctly. I'm going back and I need the key set URI, which I think it was the one on 7070. So if I'm going here, I should be, so here it is. So port 7070, well-known OpenID configuration. Port 7070 was the authorization server that issues JVT tokens. So that's why here from this one I will copy the key, the public key address. Guys, if you don't know what I'm doing here, it might be because you didn't follow the previous lessons. Because sometimes different new followers just join my live and they don't understand and feel frustrated, remember that now we are discussing lesson 17. So if it's something that you don't understand, it might be because you didn't see one of the previous lessons. So for example, the JW keys and point we have already discussed in one of the previous lessons. So that's why now I feel confident to use them without explaining it again too much. So I'm using it again hard-coded now. Don't do that in a real-world application. Put it always somewhere outside of your code, like in the application properties, so that you are able to run it on different profiles. And then the introspection URI should be the one on port 6060. So on port 6060, we have an authorization server issuing opaque tokens. So I'm going to copy here the introspection endpoint. I'm going back, and then we can go to our configuration, but I'm pretty sure that we are using client and secret. This is the one with the details stored in the database we created some lessons ago. So I am still reusing that example. So it's client and secret, the values that I have stored in the database, if I correctly remember. So that's what I'm putting here. And this is a very good example where you should never do something like this. So client and secret here, they are credentials. Credentials are secret values. You should always put them in a vault, okay? I'm hard coding them here because it's an example and we don't want to lose too much time. But in a real world application, you put them safely in a vault. And anything configurable, you put them outside of the code in application properties. So we have configured what theoretically our resource server needs. And we should be able now to prove that everything works fine. So I'm going to run the resource server. It runs on port 9090. Okay, fine enough. It's a different port, so it should work. Let me run it. And then I will call the demo endpoint that we created. And we should be able to prove that you can call the demo endpoint either by using an opaque token provided by the first authorization server or a JVT provided by the second authorization server. And see, that way we prove that we were able to create a very custom solution that uses two authorization servers. So it's still multi-tenancy, but they are not the same. One of it uses opaque, the other one uses JVT. And then if you got everything that I said properly, you understood that you can basically have any kind of authentication provider here, even one that implements a completely custom logic written by yourself. Good, so now what we need to do is to make sure that we have the type header with the value JVT when we use a JVT, or we have another kind of header if we use the opaque token. Now we start with, let's say, the first, and we use the authorization code run type to generate the token. build 2345, and we get the authorization code up here. And now we use postman 6060 to get the opaque token. You can see clearly the access token is not a JVT. It's basically an opaque token, but we should be able to use it. Something like demo, and then the headers would be authorization, bearer, and the value of the token, type, and then it doesn't really matter what value the type header has as long as the value it has is different than JVT, so that the logic we implemented here goes on the else block. You can even completely omit having it, because the equals here, if it gets a null, it will still work. But we can just assume that we have a value like opaque in this case. And running it, oh, it's not 8080, sorry, not 8080, it's 9090, okay? The resource server runs on 9090, okay, so the port should be correct as well. And fine, we have a 200, okay, it's expected. Yes, it's what we wanted to see. We can prove that if you don't send the authorization server, it's a 401 unauthorized, so it's working the way it should. So yes, it's really working. It expects a token to allow you call the endpoint. And then now we need to prove the other way. We need to also prove that it works with a JVT, no? So let's try to use a JVT. To use a JVT, we're going on the second authorization server. And we take again the flow for the authorization code run type. So we are going in the browser. This time we are running the 7071. We log in using the only user we have in the database. We get the authorization code. We go to Postman and run the token endpoint. And of course, it's not working because you can't run the authorization code on the other authorization server. So we should change the port as well. It makes sense. So we need to run the endpoint on the correct authorization server. We took we take the generated JVT. You can, if you want, you can even go here and JVT.io and try to validate the content of the token, but it's just the normal token, so nothing special here. And then we go back to the same endpoint, but instead of the opaque token, we use the JVT, and of course we need to correctly specify the header, the custom header value that we have used, so that it goes on the if branch and return the right, and it's still working. And yeah, of course, if you don't provide it, again, it's a 401, or if you provide it like this, but you have another value here, like for example, you want to go with the JVT on the opaque, then it's still a 401 because you can't validate this token on the other authorization server. So it needs to be correct. So that's how it's working, and it's working the way we expect it to work. So see, nothing complicated. We can customize as deep as you want the resource server. It's easy, and we could do that basically in 30 minutes. Go through customization of the multi-tenancy for our resource server. Why don't you try the new UI of IntelliJ? I'm not sure. I didn't even know that IntelliJ had a new UI, sorry. So I'm not that much deep into IntelliJ. I don't really care about IntelliJ that much. And as long as this UI works fine, I love it. I work with it. Cool. So hopefully that made sense. Now, I always recommend people debug things when they don't understand. So if you really want to see what happens and really understand, you can anytime add a debugger breakpoint and run it. And when you run one or the other, you can see exactly the logic that I was explaining a little bit earlier. So you see it enters here, so it goes on the JVT authentication, and that means it will use this object that knows how to validate the JVT tokens. Otherwise, when it's opaque, it would go here on this provider that knows how to introspect the authorization server, the right authorization server, in case of opaque tokens. So that's basically it, and that concludes our discussions we started in the previous lesson. And I think now, and I hope now, that everything is clear in terms of multi-tenancy, which means that we completely covered everything that is part of the OAuth, and we can step in the next lesson on a totally, completely different subject. We still have a lot on our roadmap. It should be CSRF, we have the course that we didn't discuss, we have the reactive application, and of course we have testing. So a lot of things that we still need to discuss, but hopefully now you know everything about OAuth and OpenID Connect, and you can apply anything in your applications. As usual, the code that I'm writing here is in my GitHub account, and you find the code for each, the link for the code for each lesson in a comment for each video itself. You find the code, it's free and it's available. I usually share it a day or two after recording any video event. With that being said, guys, thank you very much for being here with me again. So I'm going back to my main camera and I'm waving goodbye, and hope to see you again live for the next lesson to discuss one of the other subjects that we have on our roadmap. Cheers everyone, and have an excellent day further.